Welcome to I'm Not Afraid of Math Anymore, Math Foldables. In this video, we will look at more algebra functions and graphs, and we will learn about quadratic functions. Quadratic functions can be shown as an equation, as a table of values, or as a graph, just like linear functions. Suppose that you need to determine the area of several sizes of a rectangular building. The length will be x plus 3 and the width will be x minus 1. Notice that both the length and the width are binomials, so they each have two terms. Multiply the binomial length and width of the rectangle below using FOIL to determine the area. Creating the equation. X plus 3, which is our length, times x minus 1, which is our width, will equal the area. Then we will use FOIL. X times x is x squared. We put that under the F. X times negative 1 is negative 1x, and we put that under the O. Positive 3 times x is 3x, and we put that under the I. And last of all, 3 times negative 1 is negative 3, and we put that under the L. We combine our like terms in the middle. Negative 1x plus 3x is 2x, and we end up with x squared plus 2x minus 3 is equal to the area. Remember that quadratic functions have three forms too, just like linear functions. We have already created our equation to find the area of the rectangle when we multiplied the binomial length times the binomial width. We then used FOIL, and we discovered that x squared plus 2x minus 3 is equal to the area. Our next step is to evaluate the equation. Remember that we do that by choosing some number values to put in for x, working the equation, and seeing what comes out for y. In the first example, we have put in 4 for x. We do the work of that equation, and we see that our area is 21. We can then put the 4 and the 21 in our table of values, which is also creating a point. And we can graph that point in the graph. And as we do that with all of these examples, we see that the graph of a quadratic function will create a curved line instead of a straight line like we had in a linear function. Also notice that some of the numbers that we put in for x do not give us reasonable answers for area, such as this one with an area of 0, this one with an area of negative 3, this one again with an area of 0, and this also would not be a reasonable amount to put in a negative 4 for our x or a negative 5. So really it's just these first three examples that are giving us real results that would be reasonable in real life. So all of the examples help us to see that the quadratic function will create a curved line, but only these points here will be giving us realistic results for the area of the rectangle.